Good afternoon, class. Today we're going to be doing a presentation on recycled concrete. In our group we have Brandon Vollmer, Ryan Meyer, Stephen Werner, and myself, Justin Friesen. I will be talking about the environmental effects of recycling concrete. The impacts of concrete industry as it stands. The concrete is one of the major two producers of CO2 in the world. It produces between 5 and 7% of the world's CO2 emissions, and there's over 1.6 billion tons of concrete produced annually. Aggregates and water and other additives to the concrete only account for roughly 7% of the carbon emissions, but that is still a substantial amount on the whole scale, as well as the gravel mining for fresh aggregate produces massive scars on the environment. What is achieved by recycling concrete is it reduces the demand for steel in the steel industry, so reduces the need for gravel pits, reduces truck pollution costs, as well as reduces space taken up in landfills. Recycling just 1 ton of concrete can save up to 5,100 liters of water and 900 kilograms of CO2. Replacing the natural aggregate with recycled concrete also lowers the need for aggregate mines, which are usually put in sensitive or riparian areas where there's a lot of gravel and rock and other sensitive ecologies. That's in a picture of an aggregate mine. You can see the trees around it and the river areas, which are easily polluted. Rebar is also recycled out of concrete, which reduces the need or the impact of the steel industry. It is crushed and the magnets take the steel out, which is melted down. Just a picture of some of the rebar that's shown in recycled concrete. There is, as I said, massive amounts of recycled concrete in the world, and every year there's massive amounts destroyed. So the amount of concrete that is in landfills is very substantial, and the amount of land that's used for landfills in every city is very limited. So we really reduce how much concrete ends up in the dumps. And rubber, paper, and crushed glass can also be used as as aggregate, and that also further reduces the need for aggregate. Now we'll have Stephen talking about the viability of recycled concrete.
Thanks, Justin. The viability of recycled concrete is important to determine which applications it can be used for. As it stands, there are 3 types of recycled concrete: reclaimed concrete materials such as sidewalks and concrete roads, returned crushed concrete, which is unused concrete that's being returned to the cement mixing plant, and construction demolition waste, which may be contaminated. Some of these contaminants could be wood, glass, plastic, and in my case, beer bottles, beer cans, and organic matter. And usually this contaminated concrete is rejected. However, if some of these contaminants can be removed, then the concrete will be used. One study found that the European countries have standards for over 90% concrete in their mix, where others are 95%. This could be 5% other. The study also found that residual cement was left over in the recycled concrete, which created complications during the mix design. Increasing the water-cement ratio in conjunction with the addition of fly ash and nanosilica will counteract and decrease in strength and durability. It was found that a 20% replacement of coarse aggregate to recycled concrete aggregate would increase carbonation depth and increase compressive strength by 5.8%. An American standard found that 30% replacement of natural aggregates resulted in little effect on mechanical properties. However, a California standard dictates that no recycled concrete aggregate be used in structural purpose. However, all coarse aggregate can be replaced for minor concrete applications, with only a limitation when it comes to fine aggregates. However, as you can imagine, it's off-putting to use recycled concrete if you need to use unfamiliar standards. That's why one study was conducted to find a method to have recycled concrete with similar coarse aggregate and mortar that resembles and has similar properties to natural aggregates, in order to use the recycled concrete with more commonplace standards. This is the equivalent mortar volume. In this method, recycled concrete aggregate is treated as a 2-phase composite of residual mortar and the original natural aggregate. It quantitatively includes the volume, fraction, and relative properties of each phase. which allows us to use the original standards. This table shows the results of their study. As you can see, the 28-day strength is similar to natural aggregates for both tensile and compressive strength. Now Brandon will talk about the uses of recycled concrete.
Alright, in this section we'll be discussing the uses of recycling concrete. Recycling concrete has many different uses, some of which may include reducing the environmental impact by not requiring as many trucks, which will reduce pollution emissions and in turn will reduce costs. Recycling concrete is also a valid substitute for dried aggregate as a base layer for an asphalt pavement and will serve as an alternative for as a non-renewable source. Additionally, if concrete is not being recycled, it is brought directly to a landfill, which can obviously be avoided and save valuable landfill space. Referring to this diagram of the life cycle of recycled concrete, we can see it simply by eliminating the step of manufacturing cement from scratch will save a lot of resources and money for many parties involved in building of a structure. Recycling concrete has many different applications aside from resource savings. These include using them as a dry aggregate if and only if it is free of contaminants. Methods used to check if concrete is free of contaminants may include, but not limited to, a physical examination of a section of demolished concrete and picking out a section suspicious of contaminants and sieving it. Recycled concrete can also be used as a base layer for asphalt pavement through a process called rubblization. Rubblization is the breaking down of concrete pavement into smaller pieces and using it as the base layer in an asphalt pavement. It can also be used for decommissioning of nuclear power plants. There are other ways to reduce costs, as well as bringing a crusher to a construction site. There are large crushers that can crush up to 600 tons per hour, and smaller ones that are obviously more agile can get around more that can crush up to 150 tons per hour. The system of crushing on site consists of a rubble crusher, side discharge conveyor, screening plant, and a return conveyor for oversized materials. This is the crusher. Recycling concrete can also be used as a gravel subbase in the lowest layer of roads according to the U.S. Federal Highway Administration standards. Other uses consist of using larger, possibly unbreakable pieces as riprap for streamlines, using smaller, more average-sized pieces for landscaping purposes, and using average-sized pieces to create a gabion, which can be used for flood control. These are example pictures for the following. As concrete is reused over and over again, it will lose its ability to regain some of the compressive strength over a given amount of time. Earlier generations of concrete, and being first and second generations of concrete that will be used earlier on in the life cycle, as in not being reused earlier on. Recycled concrete in later generations may be used for different applications than later generations due to the change in the compressive strength over time and it having to take a longer period of time in order to reach its full optimal strength. I will now hand it over to Ryan to discuss costs.
Thanks, Brandon. So, one of the things we have to look at is the cost of recycled concrete aggregate. Once we've determined that recycled concrete aggregate is environmentally friendly and it can be viable as its compressive strength and tensile strength is comparable to new concrete, we have to look at the cost, because if this material costs 2 or 3 times what virgin aggregate costs, it will go unused. The various cost factors that affect this are production and transportation. If you compare it to virgin aggregate, the production is done possibly on site, whereas virgin aggregate is produced in a mine somewhere far away. Then that comes in the transportation. If you produce your recycled concrete aggregate on site, it will be much cheaper, whereas a virgin aggregate has to be transported, often a very large distance. So if we aim to lower the costs for recycled concrete aggregate, it can become very competitive. The ways to lower recycled concrete aggregate cost are to reuse aggregate on site. A great way to do this is a great example would be of regrading a highway, where you can take off the top layer of rigid pavement and use that as a subgrade if you're widening a highway, for example. Another thing you can do is use efficient graders, which Brandon already mentioned. You want the right size grader so that you don't pay too much for the machine, but you also don't pay too much for labor. You also want to ensure that you have a well-graded aggregate so that you have the right proportions for your coarse aggregate. If you don't have a well-graded aggregate, then you might have to supplement this with virgin aggregate, which will increase your cost. Thanks for listening.